We're back on section 3.4 and would like to discuss physics application to kinematics. So kinematics is the study of motion without considering of mass or force, and it's all about calculus. In fact, the original motivation for Newton to develop calculus as a separate branch of mathematics was this. So let's start with information we already know. Quantities such as distance, velocity, acceleration, and jerk are related as follows. First of all, let's put a symbol for each one of them. Distance S of t, velocity V of t, jerk, acceleration A of t, and jerk J of t. So velocity is S prime of t, A is V prime of A of t is V prime of t equal to S double prime of t. So first derivative of velocity, second derivative of distance is the acceleration, jerk is the first derivative of acceleration, second derivative of velocity, third derivative of distance. And the units are, if distance is the distance, then velocity is distance per time, and units of time, then acceleration is distance per unit of time squared, and jerk is distance per unit of time to the power 3. We often use h of t for height instead of s of t when the motion is vertical. And we go to a question. And so one big application of kinematics is in physics. It's the how we model gravity. In physics, polynomials are used to model how gravity affects the height of a projectile. Gravity on Earth provides a constant acceleration of negative 9.8, and that's something you heard before, meter per second squared, and that's approximately negative 32 feet per second squared. And so and by the power rule, the degree of the height function h of t is 2 higher than the degree of acceleration. So if I'm using polynomials and acceleration is a constant, so it just I know that it has to come from something with t squared. When I take derivative twice, I end up with negative 9.8. And so let's assume h of t is pt squared plus qt plus r. Take the derivative of it. So a polynomial of degree 2, that's what the constant acceleration tells me. And then so v of t is going to be 2p times t plus q. And see, p and q and r are constants, by the way. This is the variable part is t squared, t and r is completely constant. So when I take the derivative of this, it's constant coefficient times 2t, and then derivative of this one is just q times derivative of t, which is 1, and derivative of constant by itself is 0. Then a of t is the derivative of, when you take the derivative of v of t, you get a of t, and here q is the constant by itself, so 0. 2pt is going to be just 2p, it's a constant coefficient, times derivative of t, which is 1. So 2p is going to be equal to negative 9.8. And so that's the first thing to go. P is going to be negative 4.9. Now, how about Q? And how about R? And so what happens in here, if you go back in the velocity function and you plug in t equal to 0, you see that v at 0 is going to be q. So v of 0 is going to be q. And then you see that if you plug in 0 in the h of t, you get r. And that's h at 0. So height at 0 is r. Q is the velocity at 0. And so you can write the height of t as form of negative 4.9 t squared plus v0 t, that's v naught t, plus h0. And you can use this until toward the end of the semester, we're going to ask you to do some process that is called antiderivative, and you drive every formula every time. So now example 3, it's kinematics. A pineapple is thrown into the air. Its height in feet after t seconds is given by the function h of t equal to 24 plus 40t minus 16t squared. Questions: what are the initial height and velocity? When will the pineapple hit the ground? 3, how fast is it going to be then? What is the, and then 4, what is the maximum height that pineapple reaches? And so to answer these questions, first you have to remember the kinematic formula that we had in the before. This is going to be the half of the acceleration, and this is the velocity v sub 0, and this is height at 0. So v sub 0 is v sub 0 is equal to 40, and h sub 0 is equal to 24. And so and again, we're counting that going upward is the positive direction. When will the pineapple hit the ground? What does that mean? It means that when is the height of pineapple is going to be equal to 0. It's thrown up and going to go up and going to come back down, but it doesn't start at height 0. So what you need to do to find when it's going to hit the we were literally asking you to find t such that h of t is equal to 0, and the t has to be a positive value. So you said 24 plus 40t minus 16t squared equal to 0, and you solve. And then when you solve for t in here, you can find the velocity function and plug that t back into the velocity function. So if I solve for this quadratic equation, I can, one way is to basically factor it out and then set it equal to 0. It factors into 8 times 1 plus 2t times 3 minus t, and so the answers, these roots are going to be t equal to 3 or t equal to negative 1/2. This one's not acceptable because negative time is not acceptable. 3 is the time that it hits the ground. How fast is it going then? I have to take the derivative of that. So velocity is h prime of t. Derivative of 4t is 40, and 40t is 40, and minus 16t squared is minus 32t. And so the next part is I want to find the velocity at that time. So I have to plug in 3 in there. Velocity at 3 is equal to 40 minus 32 times 3, which is 40 minus 96, negative 56. Oh, this is a negative number because when it's hitting the ground, it's going the opposite direction of the positive direction. So this time was in seconds. And this is going to be in feet per second. Okay. Now, what is the maximum height of that the pineapple reaches? Okay. So when does the pineapple reach the maximum height? Goes up, up, up. The speed goes up. Here's the velocity. Speed goes up until the velocity becomes 0, and then it comes back down. And so if you set the velocity equal to 0, you get the time that actually it reaches the maximum height. And that gives you t is equal to 40 divided by 32. 40 is 8 times 5, 32 is 8 times 4, so 5 or 1.25 seconds. Now, to find the height at that time, I have to plug this one in back into here. And the value is going to be, if you plug it back in there, the value is going to be 49 feet. So there is another way of actually finding 5/4, and that's the because the height is a parabola, the time that it reaches the maximum is exactly midpoint of the 2 roots of the parabola. So if you could have averaged those 2 out, you would still get the time 5/4.